Hi, I'm Christopher Tracey. I'm with NatureServe, and today I'm going to talk about 40 years of Riverscour habitat studies. This is work that I participated in with Ephraim Zimmerman, both back when I worked with him at the Pennsylvania Natural Heritage Program. So Riverscour is a unique habitat that's found along high energy rivers. The way that we've been thinking about a lot is these rivers in the central, across the central Appalachians, down into this, and moving down across the southeastern US. And these habitats are frequently flooded by high energy floods that knock down the competing vegetation and um, and create these open grassland habitats that are habitat for numerous rare species. And we define these, formally as these open riparian habitats with stable substrates, along these high gradient streams that do not have a lot of woody vegetation and, some loving rare plants grow. This particular study takes place along the Youghiogheny River in southwestern Pennsylvania. It's in this section of the river, it cuts through Laurel and Chestnut ridges. It falls several hundred feet in elevation over the course of, as it cuts through these mountains, forming a gorge. There are about 20 Riverscour sites that are found across this, ranging from upstream, and then several miles downstream. Our focal species for this study is beautiful Barker's buttons, Marshallia pulchra. It's a globally vulnerable species. It's critically imperiled in the state. All of the populations in Pennsylvania are found along this river, and this is the northern extent of the species range. Some of you may know this species by an older name, Marshallia grandiflora. It was recently reclassified or redescribed as a new species. Over the course of the time, botanists have found the species and have been interested in it, beginning here in the 1880s, and moving up to present day. It's been a favorite species of study. Our records in our database go back into the 1880s, but you can see our visitation and discovery of these populations really started in 1982 when the Pennsylvania Natural Heritage Program was founded. This was one of the probably our first rare species that the program worked on and began to document. And you can see that in the 80s and through the and then picking up again in the 2000s. We've done a lot of work, a lot of survey for the species. We found several new populations, rediscovered old populations, and documented what's going on here. Darker circles on this graph indicate when the species was present, and the lighter circles noted, when it's absent. You can see that a few of these populations have become extirpated or presumably extirpated in recent times, where they have not been found in some of our recent surveys. Looking at that graphically, this map shows the same scour sites as that previous slide, and then the circle here, the larger the circle, shows a greater amount of decline of that particular population. So the larger circles on here show a 76 to 100% decline in the population size from the initial size noted down to the down to the current size. Not many populations have, if any, have really increased in size over time. So it's either typically a stability, they are stable or declining. All right, and looking at our Natural Heritage Program database and the information contained within that, these are notes by some of the biologists, and you can read through these. You can see that frequently changes in river water quality and hydrology may be impacting it. There's a number of notes about trampling, either from people hiking or from rafters and kayakers who use this river for whitewater recreation. They may be impacting the site as they, as stops or areas where they take out their boats. This river is dammed here at in the upstream end of it, in the kind of the southwest corner of this map. There is a dam just offsite here, so this river is flow regulated, and there has been some potential impacts of that regulation over time. So we started to put together this an idea, some conceptual ideas about what might be driving this Marshallia decline. And we've been thinking about this really in two forms: this watershed level. These are issues like flow management, climate change. This can affect it in two ways. One, there might be changes in the amount or seasonality of the flow, with more precipitation events as rain in the winter when it used to be snow. Similarly speaking, there is some evidence of ice scour being important on this river, but due to warmer winters, less ice may be forming on the river. And then these site level effects, such as trampling, I mentioned the recreation impacts before, but also invasive species. Currently, there used to be a significant amount of Japanese knotweed along the riparian areas of this river, and many of them on these Riverscour sites due to management activities that Ohiopyle State Park has undertaken. The abundance of Japanese knotweed is significantly lower than it used to be, but we are seeing currently an increase in Oriental bittersweet. And then there's also at one of the sites there is a bridge that may be impacting the flow of water over the site during these high water events that provide the scouring action at these sites. So just to go and look at it, here's some images from a trail camera. Here's one of the Riverscour sites. You can see this is how it typically looks in its natural setting. But this site, these open habitats on the river are really popular with people. And here's the same site on the same day, and you can see that there's just a lot of people visiting this site and walking through it, swimming, other recreation, and it could be impacting the species that typically inhabits these vegetation and sediment-filled crevices on these sandstone outcrops. Similarly speaking, with other recreation impacts, you can see a number of kayakers who are running the rapids along the site, and they have stopped here for a break or whatever, and they boats get dragged across the surface of these scours, potentially impacting that vegetation as well. Looking at these crevices right here, here's a relatively recent photo. This was taken in the early spring before things are really greened up. But this is with this particular crevice here, you can see there is typically vegetation in it. Some of these, one of the species in there is the Marshallia. Here's a record from the PNHP slide library of this same crevice here. That was from 1992, so nearly 30 years previous. Each of these, you can see along this transect, and each of these index cards indicate a Marshallia plant. One of them's right here, a couple more up here. Some of these species still do persist here, or some of these individual plants are presumably the same plants do persist there, but this population has declined a lot. And one thing that may not be as evident in the photo, but there have been some changes in the amount of sediment that these crevices and areas are holding. With currently, there's less. This is a little bit deeper and less filled with sediment than it appears to be in the older photo, and that may be driven by changes in hydrology. So these sites flood. Here's another Riverscour site under relatively high flow conditions. You can see that a lot of it is underwater. As this proceeds further into the summer here, the site would be a little bit more exposed. The water level is typically lower, and there is more vegetation that covers the ground here. Looking at the hydrograph for the site here, in this is the hydrograph. This is for 2020. And the dark blue line here indicates the mean value of flow at one of the two gauges on this river. Throughout the year, the lighter blue shading indicates the range of values over the past 20 years at that gauge. And this gray shading here indicates the time of the year when Marshallia is typically flowering and beginning to fruit. One of the times we think is the most critical for this, for that species to not be flooded. So the typical hydrograph for this shows that we do have higher flows during the winter. Typically, there is a larger flow in the spring as snow and ice melt, and the water drains down to the river and out, and then relatively dry during the summer, and then again picking up in the fall with higher precipitation events. One thing to notice on this is that during the summer you can see these little peaks in the flow. This is due to recreational use of the river. This river is one of the only rivers in the U.S. that's congressionally authorized for whitewater recreation, through flow regulation on the dam. So every weekend there's typically a slight increase in the amount of water being released by the dam to go and support the whitewater recreation. We've long wondered if this has had an impact on populations of Marshallia as either through direct inundation of water or to increase soil moisture, which may have a negative effect on the species. And through some work that we're conducting with Chatham University, we're beginning to go and dig a little bit deeper into that. And three things that we've learned is that over time, from 1990 to 2020, the average flood frequency has increased, and these are typically smaller floods, what they call in hydrologic terms the triple median value, have increased over time, whereas the average flood duration is declining over time, but the flood volume has not really changed over that time period. So we're seeing increased flooding for shorter amounts of time, but at a similar volume to what we've seen across the 30-year period. To dig a little bit deeper into this, Ephraim and I went out and we installed trail cameras. These are ordinary trail cameras that we attach to trees within or adjacent to the scour zone. These were set to go and record images every 15 minutes throughout our study period. We routinely went back every few weeks to go and change batteries and memory cards and have a fairly continuous record of flow on these rivers. And the purpose of this was to try to capture these high flow events because it's a very difficult site. These are difficult sites to get to when the river is flooded. And definitely a safety hazard to go and prevent that may to go and be down there during a high flow event. We also took, as part of this, we created a high resolution digital elevation model by flying a drone. We captured a series of images, which we then translated into this digital elevation model, which occupies kind of the central channel here. And this was a model that was about 3-inch resolution model compared to the 1-meter resolution model that's available for outside, or that's available for the rest of Pennsylvania. And this DEM was used by the Army Corps of Engineers to go and integrate into their HEC-RAS flow model. So we were able to go and get more precise estimates of which areas of the Riverscour are inundated during a particular at a particular flow level. Looking at some of our camera data for this, for the site, here's the river at a typical, low flow condition. This is about average for the late spring, early summer, and about the maximum flow that they use that they put out for whitewater recreation. Here you can see a much higher flow event. This is 8,700 cubic feet per second. This would be classified as probably a small to medium-sized flood. The river can get up to the neighborhood of 14,000, 16,000 cubic feet per second in a really large flow event. So in addition to having these individual photos, we were able to take them and turn them into these hydrograph videos, where we're able to go and overlay the hydrograph for the river on on this time-lapse video of what the river's doing, so we can go and begin to see what happens at particular flow. So as this goes and begins to increase, you can see we can see how water rises across this, how water is moving across the scour, which areas drain first. It's actually in many of our videos we've seen a lot of how logs and other debris move across the scour and knock down vegetation, and get a lot of information about what goes on, information that we had not seen previously. Taking this information and tying this with our digital elevation model and the Army Corps HAC-RAS model, we were able, for a number of sites, we were able to get information like the number of days that more than half the area of Marshallia on the site was above a flood threshold. And you can see that this varies across our 5 sites, it depends a lot on local topography. But some of these sites have shown significant, that you can see that they go and they get flooded. The Marshallia populations at these sites get flooded, fairly frequently. Most of that happens in the winter and early spring, during these high flow events. But also September, it does seem to happen quite frequently. And this is probably important because this is when the species is probably dispersing seed. And for some sites, especially in sites that we have seen notable decline to Marshallia, we do see some increased summer flows. Drake's Run is the site that's closest to the dam, and may be more directly affected by those summer whitewater releases. Speaking of whitewater, some rafters going by one of the sites. We've also begun to think a little bit about how sedimentation and deposition of sediment goes and affects this. Here's a Marshallia plant. This was after a late summer high flow event, and maybe hard to see in this picture, but there's about 2 to 3 inches of sediment that's been deposited on the site that's buried part of this plant. But the plant seems to respond pretty well to that. So, beginning to go and learn a little bit about what's happening there and think of the next stages of research for how to go and understand what's happening at the site. Looking at the, we've done a lot of work to try to understand what's been happening over time. This is the Ferncliff Peninsula. This is the tip of this does have a river scour on it. It's a somewhat unusual position for a river scour. Most of these river scours are found on the outside of bends or near rapids, but this one is on this inside of the bend as the river makes this goes over a waterfall and makes this very sharp turn. This site's been typically one of our larger Marshallia populations. This photo is a slide from the late 1960s, early 1970s. That we found in our slide collection and scanned. And here's a similar photo taken from a drone in 2020. One thing that you may notice on here is that there's significantly more trees here, maybe a little bit difficult to see here, but there's a number of sycamores that appear to be present here in the modern times that wasn't there previously. So there are changes happening on the site where there's increased woody invasion, whether that's due to changes in hydrology, changes in the amount of ice that may have previously prevented sycamores from establishing or growing as big. Has been a factor in this, but so it's an area that we'd like to gain more understanding on. Okay, so some of the outcomes of this hydrology study is that we have gained this increased understanding of the frequency and duration of these high flow events. Generally speaking, we think that the weekend recreational flows, these where the rivers rise to 1.8 to 2.2 feet, or about 1,000 cubic feet per second, are not affecting the extant populations of Marshallia. We can't say a lot about how that may have, what that may have done historically. If there are areas that were previously occupied earlier, or decades ago, that may have been affected by the dam. The dam's been in place since 1940. Most recreational activities there have been in place since the 1980s. Our earlier surveys may have caught the tail end of some of that decline of Marshallia, but we currently don't have the data to really fully understand what happened there. And then we definitely need to understand more about washing and deposition of sediments across these river scours. And I'll end right here with just another historic photo. This photo is again from the 1960s. And this shows a river scour right here at that's just past actually the base of the Ferncliff Peninsula that we saw in the previous slides. And this is the Route 381 bridge here. And something that we have noticed over time is this particular scour has gone and grown in a lot, and the Marshallia has declined. Number of reasons for that. Probably, the site is right next to a parking lot, right near a very popular area of the park. So so it's a highly visited site for recreation. But as we've seen, increased shrub and tree growth on the site, as well as just grasses and other herbaceous vegetation, it's become closed in a little bit. And we think one thing that we can see, one thing that we've hypothesized is happening is these piers from the Route 381 bridge deflect the water away from directly hitting the scour. So there is very limited removal of that vegetation. And so much so that when we have been out here after high flow events, most of the vegetation is actually pushed down facing upstream. And there appears to be an eddy that's created from this bridge, and the water swirls around and is actually flowing over the site in a backwards direction, so to speak. This is really interesting to us. We've been trying to think about ways of restoring the scour. And last year we did have a meeting with Ohiopyle State Park and representatives of Pennsylvania DCNR to go and discuss the site and think about using it as kind of a test area where we can go and think about ways of managing these scours, through manual woody plant removal, also testing ways of alerting the public about these, about the rare plants here, testing ways of guiding people away from trampling or disturbing them. So we're trying to take this information and turn it into on the ground action, to better manage these habitats and the rare species within. And with that, this project was made possible by a number of collaborators from a number of different organizations. And we appreciate all the work that went into this project from everyone. Thank you.